As you can see here, we first open up a little sample project that we set up. It's just a simple grade school homework helper that calls an LLM, helps you with your grade school homework. And as you can see, this one runs on GPT-4o, a somewhat frontier model. And the idea today is that we're going to be able to replace that with a much cheaper, more specialized, fine-tuned model instead. So first thing we're going to do is head into our terminal, open up our CLI tool, and it's going to go, well, first we'll usually start off by initiating. So we're going to hit Nabla init. Since I've already uploaded my API key before, I'm just going to cancel so I can go ahead and run my other commands. We're going to do Nabla scan, which goes ahead, scans our repo for all possible call sites, so anywhere where an LLM call is being made. I have a few other sample repos just scattered throughout just to test this parsing capability. But the one we're going to be focusing on today is a function called problem solver, which, as you saw before, calls OpenAI to solve a grade school math problem. So we're going to go ahead, we're going to do Nabla capture. Now what this does is it captures relevant parameters and it generates a few relevant test cases in the event that no prompts have been run yet. So we get those, format that into JSON, and then eventually we do a final JSON, which we named it Nabla Jeremy, and this develops the goal, which will be very important later on. And then once we have all our JSONs nicely formatted, we just go ahead, upload those to our backend by running Nabla push. It hits our LangGraph server and hits our multi-agent research system.
Next, we can move on to the task generator preprocessing. So here we can see we're using Langsmith, which generates multiple agents, and each of these agents will have different tool calls to have access to a database of previous tasks. These tasks can then be run against the student model, and based on the pass rate from the student model, we can determine if the pass rate is low enough that it provides a challenge to the model and can be used for the task generator to continue training this model further. Here we can see another agent that's also being used. In this case, this agent does a little bit more research, as we can see from that tool call, and it also allows it to come up and generate new problems that are not part of the database, again, also validating it against the student and identifying the pass rate to then determine whether or not it gets accepted.
And approve the job that we have queued up, and then we can head over to our overview page where we can see the task run. Here is asymmetric self-play, in which we have a teacher agent and a student agent, and the teacher's job is to generate tasks, and it gets rewarded based on how good those tasks are, so not just how easy they are for the student to solve, but both how challenging they are, and then also still being solvable enough for the student, while the student just gets rewarded for solving the questions. The idea is that eventually these two would stack on top again and again until we kind of have a sort of self-improving system, and we improve that to a point where it can compete with frontier models, and then we let it stop, and then we kind of workshop and see where we're at. Once the task is finished running, we can go ahead to our workbench. We can see how the iterated copy compares to the base copy, and we can run a few different prompts. Right now, I'm just going to put in some easy grade 12 question, and as you can see, the prompt that iterated over it 3 times is actually able to fully solve the question within the context window, while the other one kind of goes awry and then slightly comes back before going off track again, and then eventually runs out of context for solving the question. We also have a metrics page where we can see improvements over iterations. We can see what questions models might have failed on before, but we're able to actually answer successfully in future iterations. And this information can be very useful for our customers who might want to use this to do their own evaluation further down the line, maybe tune some own weights or change some reward functions just on their